Before we head over and work with Rapid Spanning Tree Protocol a bit, I wanted to mention one other difference between STP and RSTP, and that's the fashion in which the BPDUs are generated and really where they're generated. Because with STP, the root bridge generates and transmits BPDUs every 2 seconds. And the non-root bridges, they read them, and then what do? They relay them. Well, with RSTP, it's a little bit different. The switches generate a BPDU every 2 seconds, regardless of whether they have received a BPDU from the root in that period of time. Now, the hello interval and the max age and the forward delay, the timer values are the same by default. And we'll see that on the live equipment here shortly. But again, the RSTP enabled switches are creating their own BPDU regardless of whether they've heard from the root. Now, this is a pretty slight change in operation, but it's an important one because it allows all switches to have a role in detecting link failures, and the discovery of the failures is a little bit faster because every switch is expecting to see a BPDU from its neighbor every 2 seconds. If 3 BPDUs are missed, the link is considered down, and here's the important change. The switch then immediately ages out all information that's concerning the port that was receiving the BPDUs. Okay, so there's no max age involved here, and this really cuts the error detection process from 20 seconds to 6, because when a switch running STP misses a BPDU, the max age timer kicks in, and that timer, of course, as we've learned, dictates how long the switch is going to keep the contents of the last superior BPDU it received before that information is aged out and STP starts the entire recalculation process. Nothing wrong with that, but we kind of like this with RSTP, where the superior BPDU is aged out immediately, all the information concerning the port no longer receiving the BPDUs when 3 hello time intervals pass without it being refreshed. And that's good stuff. We'll take every second we can get. Now we're going to see RSTP in action on the network I'll show you in just a moment, and the only non-default command I have running on here right now is spanning root primary, and I put that on switch 1. So if I'm running the defaults, I'm running good old spanning tree protocol, right? Well, let's check it out with our verification commands, and actually a new one I want to show you as well, and the new one is on the board right now. Show spanning summary. And this is a good one. Especially after you've gotten a little deeper into some of the Cisco switch features like uplink fast, backbone fast, that kind of thing. There are several things here that we have not worked with yet, but one reason I really like this command is the very first line of the output is going to show you what mode the switch is running, and we're running right now PVST per VLAN spanning tree. Now that information is shown elsewhere, and before we go on, I wanted to show you that when I ran this command as well, you can see at the bottom of the output with learning 2, so 2 ports on the switch were in learning mode when I ran this command, and 2 of them, the same 2 of course, are active with STP. So let me run it again now, and we would expect them to be in forwarding mode, and indeed they are. There's another way to see what mode you're running in, your switch is running in, and we actually ran this command quite often earlier, but we were concentrating on other things to say the least. Let's run show spanning VLAN 1. We see the usual information here, but one line we might have overlooked is this one right here. So for VLAN 1 right now, we're running spanning tree enabled protocol IEEE, which means we are running per VLAN spanning tree and not the rapid version. We're going to change that right now, and we're going to do so with the spanning mode command. Now, depending on which switch model you're running, you may not have all of these options. Not every Cisco switch in the world will run rapid PVST. Multiple spanning tree, we're saving that for another day. In this course, we're concentrating on PVST and rapid PVST. And let's go ahead and put rapid into operation. Let's see if we get any console messages or pigeons or balloons being released or anything like that. Doesn't look like it. Okay, well, let's just go ahead and run show spanning VLAN 1 and see what we see. And there's one major difference right here, spanning tree enabled protocol RSTP. Now notice the ports are in blocking mode right now. I don't think they're going to stay there, but you should expect that right after you switch over, if you will, from one version of spanning tree to another. So let's go ahead and run that again now. And notice they're in forwarding mode. And, the priority didn't change, of the root, because this is the root. So let's look at the local information. Priority didn't change. MAC address didn't change. System ID extension didn't change. Timers the same. Aging times the same. Everything's the same. So no major changes, but one thing I do want to show you while we're here, and this is great real world stuff. I doubt seriously it shows up on your exam, but I see this question online a lot. It's like, okay, I enabled rapid spanning tree protocol. I've got this weird message at the end of the output when I run show spanning, type PTP peer STP. Well, what's happening here, it's actually giving you two separate pieces of information. And the first one it's giving you is the type, and that is peer-to-peer or point-to-point. And we know what that was from earlier, right? When we showed the two, the edge and then the point-to-point. This is a point-to-point connection because it's running full duplex, and the neighbor is running full duplex. This is actually another piece of information entirely. What it's saying to you is your peer, the switch on the other end of this connection, is running spanning tree protocol, not rapid spanning tree protocol. So that's all that means, and that should go away as we bring all the switches over to rapid. It doesn't always go away immediately, but it does leave. So let's go ahead, start with switch 2. And again, rapid. And we'll hit 3 here. And we'll hit 4. Let's try that. We already did that one. And notice that the peer STP message is now gone because both switches that switch 1 is communicating directly with, switch 2 and switch 3, they're both running rapid spanning tree protocol now. So that made the message go away. Let's go ahead and run show spanning summary again. And you'll notice the very first thing it mentions is switch is in rapid PVST mode. So two really good ways to tell is either with show spanning VLAN 1 or with show spanning summary. Also notice though that the terminology at the bottom of this output does not change when you go over to rapid spanning tree. It's not going to start combining blocking, listening, and learning, putting them together and saying discarding. It's just going to keep the same information there. The important thing is these two ports are still forwarding and they're both active with STP. When we come back, we're going to go around to all 4 switches, just do a quick check on the port modes, that kind of thing, see if it's what we expect to see, and we'll move on from there.